Hi everyone, my name is Pedro, and today we'll be taking a look at first principles thinking and real-world machine learning, focusing on human-centric processes for success. Have you ever worked on a project for so long, spent countless hours obsessing over it, with an engineering team that, honestly, you think is quite good, only to see that, in the end, it didn't quite make it to production? Or even if it did, maybe it didn't stay there for long. If so, you're not alone. Many data scientists and engineers have been faced in a similar situation. But how can something so promising fail? To understand that, let's take a look about first principles thinking. First principles thinking is the art of breaking down a complex problem into its fundamental truths and building blocks. For example, when I was doing mechanical engineering, we used to think a lot about how to transform materials and processes into final products with value. So for example, if you were building a spaceship, you need all the materials, metals, alloys, and so on, in order to build that spaceship. When we're working with a data product, a similar analogy applies. But instead of alloys and the rest of the metals, you got some data, some experiments, and some engineering hours. So how can we make do with the least we have in order to drive the most amount of value? And how can we apply this to machine learning? Let's see. To understand that, let's look about why most ML projects fail in the first place. And the number one thing they fail is right off the gate, during planning. People fail during planning, usually because they build a solution that doesn't really solve the problem they're trying to solve, or it's too expensive, or they simply cannot explain how it works. The second of all is scoping. And usually people fail here because they underestimate the time it will take to build something. They spend too much time on it, and they get into that situation where you're like, I didn't realize how complicated this was going to be. And you don't want to get into these shoes. And this is what I call the Great Wall. This is where most ML projects fail. And they fail right off the gate before a line of code is ever written. So people rush through this stage because they want to get into the cool stuff. They want to get into the machine learning, these neural networks, and all that jazz. And then they fail because they fail to communicate with the stakeholder on their basic needs. But even if they pass through the Great Wall, then they go into the experimentation stage. And usually people fail here because they're very creative. They have so many ideas, but they spend too much time working on them. And they test them for way too long, for too much stuff. If they pass through that, then they go into development, but people fail here due to unstable, fragile, plain old spaghetti code. Or on the deployment side, because their solution doesn't scale as they expected to, maybe because of a bad architecture that they chose beforehand. Finally, on the evaluation side, maybe drift is causing instability and your model fails into production, or the high cost of your solution doesn't match the value added. Now, how does a successful ML project look like? Let's start with planning. Planning answers the question, okay, what do you, stakeholder, want to build, and when do you want it built by? And this prevents situations where you're like, stakeholder says, look, it's very nice what you built, but I didn't ask for this. This doesn't solve my problem. On the scoping side, we are answering, okay, what are we, data scientists, going to build, and what are we going to test? This is really important because you don't want to underestimate a problem. You don't want to be like, ooh, I didn't expect this was going to be so hard. You don't want to be there. On the experimentation side, you're asking, okay, will what I built work, and how does this compare with the other solutions that I'm also testing? And this prevents you getting into situations with the stakeholder saying, hey, I know I've been working on this for 2 months, but look, I have no idea how to solve it. They want to be there. On the development side, you need to make sure you build maintainable code, have proper MLOps integration. You don't want to be that guy that's like, oh, it ran fine on my machine, and I don't know how that piece of code works, so let me just ask X guy to fix it. You don't want to be there. On the deployment side, you need to make sure things run at the scale you need them to run and monitor its performance. You don't want to be like, oh, job failed due to an out-of-memory error. Run it again and hope for the best. You don't want to be there. Finally, evaluation. Always correct the right metrics and adjust and adapt to changes on those. You need to make sure you're answering the question, okay, is what I built actually doing what I wanted to do? Always make sure about this. Now, planning and scoping, how you can increase your chances of success before ever writing a line of code. Some key questions you need to ask your stakeholder during the first conversations. First of all, what is the project? How is this done now, if it's being done at all? How do you need to use these predictions? What business need is this solving? What would make you consider this a success? This is a really, really important question, and I cannot stress this enough. Always to define success. We just had a whole talk about it. This will help you define your experimentation, your evaluations, and your monitoring once things actually get into production. So it involves the whole life cycle of your ML project. When will you be ready to test this? And who from your team can I work with? All these are really important questions, but I know they're very hard to apply. So let's take a look at an example in practice. What is the project? Stakeholder would say, okay, we need to understand why our users are leaving the platform and prevent them from churning. Then I'm thinking, understanding might mean a bit more than just a prediction. I need to press them on this. I need to understand this deeper. How is this done now, if at all? Stakeholder would say, okay, we haven't pinned down a solid definition, but usually it's when users stop using the platform for more than 30 days. And I would think, okay, definition is quite loose, might miss some early indicators. Let's press them a bit later on this later. How do you need to use these predictions? We're thinking about targeting these users maybe with specialized offers, personal emails to bring them back. Okay, the solution sounds rather reactive rather than proactive. Maybe there's a better way to solve this. Maybe there's something else I can do. What business need is this solving? Stakeholder would say, ideally, reducing churn should lead to a higher retention, and ultimately, more revenue. Something, okay, so what he's after is the revenue. That makes sense, but it's not very clear how the customer churn affects the revenue, so I might need to explore this. Keep in mind, this is tied with my EDA and the explorations that I'm going to do later on. So all your ML project starts with conversation. What would make you consider this a success? Important question. A stakeholder would say, look, if we see our churn rates decrease significantly, then we would have more returning users. That would be a success. And I'm thinking, significantly is quite vague. I need to help them define what a realistic metric looks like. Is it 2%? Is it 4%? Always strive for this type of metrics when you can, and code them when it's possible. When will you be ready to test this? Okay, the sooner the better, but we haven't set a specific timeline. We do want results within the next few months, though. Okay, so I'm thinking, the timeline is flexible, but they need to understand that quality results take time. So let's suggest a phased-out approach for this, where they go step by step with feedback. Who from your team can I work with? Our customer success and sales teams should be involved, stakeholder says, but they're kind of busy, so I'll try to get them to help. Good. I asked this on the first meeting I had with them. Getting the subject matter expert opinion on board early on is crucial. You don't develop in a silo. Always develop with feedback. Some tips for better communication. Use calibrated questions. Calibrated questions have the power to educate your counterpart on what the problem is, rather than telling them what the problem is. And this is very good when you work with highly opinionated people, let's say. Avoid using statements like can, is, do, does, or why. Why is accusatory in almost any language, and these tend to point to yes or no. Instead, use something like what or how. These offer no attack statement like the others ones do, and they make people go into collaboration mode. This is particularly useful for you. For example, let's say you have a product manager or a product owner that's pushing for a deadline that you know for sure doesn't make any sense, and he's not willing to budge on it, and you say, look, can you get us more time to it? The model is not reliable. And he just says no. Instead, try something more along these lines. How am I supposed to deliver a model that I know doesn't work on every case? We hadn't had the proper time to test this. I wouldn't like the stakeholder trust on me, you, and the rest of the team to be affected by this, would you? How am I supposed to deliver this? It seems like you're really good at talking with the higher-ups. What can we do to make it work so that we have more time? How can we find a solution to this? Boom. Suddenly when you ask these what or how questions, the product owner or the manager is thinking, okay, how do I help this guy? So he's not fighting against you, he's fighting with you. And that's a really important, just natural language thing that might help a bit. So these are little hacks that you need to practice. Now, what you want to avoid is getting into bad communications loophole. Like, you gather the requirements, you build something in complete isolation, show it to your customer, realize it doesn't fit the needs of the customer, you say sorry, go back to the drawing board, and you can only do this so much before people start losing faith on you. You don't want to be there. And I never seen it at the first time where people go, they say, okay, stakeholder, I understood what you said. I develop in a silo and say, here's the code, let's ship it to production. And it went well the first time. I never seen it happen. Maybe you got luckier than I did. One better way to do this would be to do something a bit more agile-ish. So you do some research, you show it with your team, then you show it with the customer and say, does it make sense that I built these things this way? So yes, okay, then you build it, show it with your team, then show it with the customer. If it still doesn't fit the needs, do some more research and go in that loop. Always work with collaboration and communication in mind. Now, gather all you need. Once you talk with the stakeholder, always ask questions about data and the business impact, like data acquisition, how is this data being collected? Data analysis, how is this data being used? And what data processing? What processing occurs on this data? Is it twice a week? Is it once a week? How fresh is this data? How can I use it in production? What are the current challenges of this, the goals, and the success definition? Always gather all of this. It's a must. And once you do, consider then putting in something like a ML canvas, like a A4 spreadsheet, where you condense all this little information so you can share it with your team to make sure you didn't miss anything obvious. Helps a lot, it's quite practical and easy to use. Now, we're getting close to code, but not yet. Think about, before you start coding, always define your architecture, like high level, generally speaking. Am I doing a batch? Am I doing a real time? How am I going to make this work? What's the service line agreement? Put it in ML project canvas. Check with the previous art. Has anyone in my company ever tried to solve this problem before? If so, I can use their knowledge. Check some library exploration. Is there any open software for a similar task that I can leverage? So all this before we start code, we're already planning for success. Now the experimentation, the part that everyone goes crazy about. Setting up your experiments for success. And here we're going to take a look about two different stories of complete side opposites of the spectrum. And spoiler alert, you don't want to be either of them. Let's take a look about the 10x developers. The 10x mindset is something like, okay, talks with the stakeholder, says, thank you very much, I understood. Goes on the internet, search for a few blogs, and say, okay, found a good blog on customer churn with XGBoost. Good. Call stakeholder. Should take 2 to 3 weeks to build. What do we expect from this mindset? Extreme profit? Not really. So the business said both false positives and false negatives are atrocious, and the model is not going into production. So inadequate research, a rushed implementation, and a failure to understand the nuances of the problem led to this project to fail. Now, on the opposite side of the spectrum, let's take a look about the academic researchers. They spend more or less 2 weeks searching on I3Es, archive, and journals for prior research on the topic. Up until here, flawless, magnifico, all is well. Good start. Then they discover a highly cited paper on neural networks with genetic algorithm, and they're like, there isn't an open source implementation from this. Let's just build it from scratch. You think that's going to go well? Extreme profit? No, not really. So the business said, look, we don't have the 4 months you guys need to develop this or the multi-GPUs, so we cannot make this work. Very rarely, the cost of building something from scratch is worth it. With the right team and the right problem, it might work, but always consider that it might not be worth it. Maybe a simpler solution will do. And now you're thinking, but Pedro, these are completely opposite sides of the spectrum. I'm neither of them. Good. Maybe you are very creative and you have many ideas that you want to explore, but don't work on them too much so that everything becomes an MVP. Like, don't spend too much developing each of your ideas just to validate them. Gain intuition of what works and what doesn't. Gain it with experience. Communicate. Experiment enough, but not for too long. Don't reinvent the wheel, and don't lose sight of the problem you're actually trying to solve in the first place. Always find the simplest solution that solves the problem first. Go with the quick wins. Like, does a simple data visualization solve the problem? If no, then you go into advanced analytics, like, does a heuristic or rule-based solve this? Only if you run out of those options, then you start thinking traditional ML. Like, does classic predictive modeling solve this? Finally, after you run out of options, you don't know anything else, you think, okay, maybe I use deep learning and a deep neural network to solve this. Because think about it, as closer you get to the right, the harder it's going to be to actually put it into production. So always think about the simplest solution that solves the problem. But even if you do solid planning and experimentation, you did great development with a great team, you validated your solution, you did a successful deployment, everything is scaling, everyone is happy, but then 1 year later, the business comes and says, look, we looked at the budget for the last quarter, and this ML project is costing us like 43K per quarter. How much money are we making off of this anyway? And then the data scientist thinks, revenue attribution? And then he starts to panic. Always justify your existence, justify your value, and measure the success. Cannot stress that enough. We just had a whole talk on it. Now, how do we do this? We monitor. What gets measured gets managed. And you can measure everything from software system health all the way to business KPIs. There's multiple ways of doing this. I don't care if you use Evidently, NanoML, anything that you want to use. But measure what you can. Now, to wrap things up, you're going into code. But before you write your experiments, consider this. If I wrote my success definition before, how am I going to evaluate it? Think about all these metrics and define a contract. Always do like a little function that takes in the inputs or outputs of your model and evaluates those metrics. This is important because think about it. If I'm doing a custom PyTorch solution with an LSTM, very complicated, it's probably going to have a different input and output and schema than if I use like a common library for a similar problem, like Facebook Profit. So if I'm testing all these different ideas and I want to compare them all in the end to make sure what goes into production and why, I need to have a fair way of evaluating them. And the only way to do that is to provide a good contract so you can measure apples to apples. Always use an experiment tracking software. I don't care if you use MLflow, weights and bias, Comet. Doesn't matter. Always can be tool agnostic. Just focus on the processes. Focus on the basics. All the slides that I use in this conference are available online. Most of these are free. I'm not affiliated, so feel free to check them out. And some key takeaways here. Communicate. Don't lose focus of the problem you're trying to solve. Justify your existence. It's important, especially the higher salary you have, you really need to justify it a lot in what you build. Always measure success, and when you can, put it into code and translate it into code. And make sure that once you ship something into production, it actually stays in production. Make sure it stays there for a long time and that you're very happy with it and everyone is happy with it. Now, you're telling me, but Pedro, this is all incredibly obvious. And to that I answer, it should be. You know when you go to your doctor and he tells you, look, you should eat healthy, get some sleep, do some exercise, eat a lot of vegetables? Yeah, that's because sleeping, eating vegetables, and doing all this is extremely important. Doing the basics is hard. And doing them to perfection is extremely hard. Master the fundamentals, and the rest will follow. Thank you very much.